Okay, so in this video we're going to have a look at a pensions question. So we see here, so John is 30 years old, plans to retire when he's 65. He contributes 700 at the start of each month to a pension fund, earning 4% AER. So we see there straight away, we'll have to do a little bit of work on the interest rate. The pension will pay a lump sum on his retirement. Okay, show that the monthly equivalent interest rate corrected for significant figures is 0.3274. So we have 1.04 is equal to 1 plus or to the power of 12. So the 12th root of 1.04 equals 1 plus or. So or then, so the 12th root 1.04 we get 0.00327374, and that's as a decimal, so convert that to a percentage and multiply it by 100 over 1. So we get that our monthly rate is 0.3274. Again, when you go by 100 over 1, you get 0.3273739782. So 327, and that 37 will go up to 4. There's 5 marks for that. And then show that he'll receive that amount correct to the nearest euro as a lump sum when he retires. So this is an investments question. So we use F is equal to P times 1 plus I to the power of T. F we don't know, but we know that when we work it out, it'll equal 632045 rounded up. We do know that he invests 700, and they tell us at the start of each month, so that's fine. He's 30 years old, he's going to retire when he's 65, so that's 35 years, but he invests every month. So that'll be 35 by 12, which will give 420. So he'll make 420 payments into it, and his interest rate is 0.003274. Okay, so we get F is equal to 700 times 1.003274 to the power of 1. So we're just establishing our series here. Squared. And so on, and then we get 700 times 1.003274 to the power of 420. So now we use our sum to n formula. So that's a times 1 minus or to the power of n all over 1 minus or. A is equal to 700 times the interest. It's changing by 1.003274 every time, and n equals 420. So we get the sum to 420 is equal to 700 times 1.003274 multiplied by 1 minus or to the power of n, which is 420, all over 1 minus or. So all of that, you've done your setup work and shown your working, so all of that can just go straight into the calculator. Make sure you include all your brackets and just be careful with your smaller decimals. Okay, so we get 632,045.2202. And then they'd asked us to round it, so the nearest euro, and we get 632,045. Okay, so again, it's an annuities question, but it's a pension one, so we use F is equal to P times 1 plus I to the power T. Okay, so that's that question done. 15 marks in total, pretty straightforward.